Yeah, we should be live now.
Francis, you go to Reynolds' class.
Into what?
Tell Scally to make sure we're live.
Is your name Francis? No.
Of course it is.
No.
You're live.
We're good? So tomorrow's our midterm. I will be going over everything in micro. There are tomorrow 60 multiple choice questions, which span all the micro units 1 through 8, including factor markets. There will be 2 FRQs. This year, there will definitely be 1 FRQ on micro unit 8, which is factor markets, monopsonies, that sort of thing. The other FRQ could be on anything. Generally speaking, on the actual AP exam, there will always be, your first FRQ will either be perfect competition or monopoly for microeconomics. So I generally have that on the midterm, but as you already know, one of the FRQs ahead of time, I'm going to see what I'm going to do about the other one, but it could span anything. So we're just going to start kind of from the beginning, and we're going to do Unit 1. This is about 8 to 14% of your exam. So you do the math, 60 questions, about 10%. So we're looking at about 6 questions from this. This is everything about comparative advantage, absolute advantage, terms of trade, command economy, market economy, that sort of thing. So let's just start with market economy, command economy. I'm not even going to talk about traditional economy. You don't really see it on the AP exam. That's like, what to produce, how to produce, and for whom to produce is decided based on customs and norms and tradition. But a market economy this is what we know as supply and demand. This is free market. This is efficiency. And this is invisible hand. The command economy is a central authority with equity and no invisible hand. So what's great about this now, when I taught this in the beginning of the year, it's a lot harder, but now we can talk about things where free market is supply equals demand. That's equilibrium, that's no intervention, and so we have mass efficiency because we maximize surplus. When the command gets involved with taxes, with floors, with ceilings, that increases equity. Taxes pay for things like schools, roads that everyone can use. However, it creates deadweight loss. So there's a trade-off in economics between equity and efficiency. So kind of characteristics of market are freedom, allocation of resources based on the invisible hand, supply and demand. With the command economy, it's a central authority. The one question we've kept seeing this year about the difference between market and command is that in a market economy, remember, the command is needed, or a market economy does not ensure property rights. And that's one of the problems. That was the paperclip game we did at the beginning of the year. So that's basically all you should really know with those things. Let's move on. Let's talk about PPFs. Production Possibilities Frontier. So this is the limitation of production of a country based on its resources. Points inside the PPF are inefficient. On the PPF, so we'll call this A, B, C, and D, are all equally efficient. And then out here, this is impossible. The production possibilities frontier is limited. We are limited in our production based on land, labor, and capital. So B, C, and D is an economy using all its resources. A is an economy that has all its resources but is underutilizing this. This could be unemployment, This could be perhaps a government shutdown, could be anything like that. E is we don't have enough land, labor, capital currently, or technology to produce that E. E is possible to consume at through trade, but we'll get there later. Now we have two types of PPF. We have a constant cost, and we have an increasing cost. This is a straight line, and this is bowed out. They both show the limitations, but here, resources are equally adaptable. So we use the example Robinson Crusoe. He's shipwrecked on an island. He can either get coconuts or he can get fish. It takes him twice as long to get a fish than it does to get a coconut, but the ratio, 2 to 1, stays constant regardless of how many fish or coconuts he gets. If he gets 7 coconuts, the trade-off for the 8th coconut is still 1/2 fish. The 9th coconut, the trade-off is still 1/2 fish, because time isn't better for fishing or better for coconuts. Here we use at the beginning of the year, we use butter and guns. Generally we say like consumer goods in capital goods or military goods. But guns and butter, I like the concept because I like the imagery of a cow working in a factory. So what we're saying is when we get closer to the y-axis, we are taking resources that are better suited for butter and we're putting them in a factory like a cow. A cow is not good at using machines, making guns, making capital goods. So when we're giving up these few last resources for consumer goods or butter, they're less, I don't like to use the word efficient, but they're not as suited or adapted to making these sort of goods. So this is an increasing cost model because we have specialization. And that's really the difference. The closer you get to an axis, the more expensive it becomes. So then, generally we'll see straight line PPFs. So we'll say, let's do 100. So we can use our straight line PPFs. I know that's not the best straight line ever, but what we can do is we can talk about comparative advantage, absolute advantage, and trade. So here we're talking about country A and country B, and let's say this is corn and this is wheat. And country A, so we make our little chart here, corn, wheat, country A, country B. Country A can grow 150 corn, 150 wheat. Or 50 corn, and country B can go 100 corn and 100 wheat. So first let's talk about absolute advantage. Absolute advantage means who's the best. So what we're doing here, this is an output problem because we're talking about how many outputs we're getting with a constant amount of inputs. In this case, it's just land. So who's better at growing corn? Country B is better at growing corn because they can grow 100 versus 50. Country A is better at growing wheat because they can grow 150 versus 100. So this is the absolute advantage, the absolute advantage. But with trade, what we like to look at is we like to look at the comparative advantage, which we have to calculate the opportunity cost of corn and the opportunity cost of wheat. This is an output problem. So I'm stealing this from Mr. Clifford, but he likes to say other over. It is what you're giving up over what you get. So if country A has corn, it's 150. If he grows the corn, country A is giving up 150 wheat. So it's 150 divided by 50, or it's 3 wheat for every corn. B, it's 100 and 100, so it's 1 wheat for every corn. And then if we look at the flip, it's the inverse here, so it'll be 1/3, and it's 1 corn. But you go other over, 50 over 150 is 1/3. Comparative advantage. Lowest opportunity cost. So in this case, it's who can produce corn cheaper. Here, country B can produce corn for 1 wheat instead of 3 wheat. That's cheaper. Country A can produce wheat for 1/3 corn instead of 1. This is cheaper. If you are to calculate the terms of trade, all you do, I prefer to work in whole numbers, is you go to one of the columns here and you say the opportunity cost of corn, and you pick a number between 1 and 3, it's 2. And then what we say is country B is they're making corn. It costs them 1 wheat to grow corn. They're selling it for 2 wheat. That's better. Country A can make their own corn for 3 wheat. They're only paying 2 wheat. That's better. So that's an output problem. From this chart, we can infer absolute advantage. We can do the math and get comparative advantage. And the chart shows the trade-offs. These, again, are straight line PPFs, which means that's a constant cost. The 3-to-1 ratio is constant throughout. There's no specialization. Everything's equally adaptable. So let's do an input problem real quick. So let's say Mr. Strike can bake a cake in 1 hour, or Mr. Strike can bake a cookie in 6 minutes. The approach is the same whether it's one person. I'm not comparing myself to anyone, but I'm just showing you how to do the math. So in this case, we have a cake in an hour. We're going to put it in similar units, so we'll do 60 minutes, and a cookie is 6 minutes. You're going to go I first, so because it's input I. The other way to think about it, if I spent 60 minutes baking a cake, how many cookies could those 60 minutes be? 60 over 6 is 10. And then the reciprocal here is 1/10 of the cake. So you would just go I first. If I had another person, I would compare it. Absolute advantage with input is, again, use the word best. So it's fewest resources. In this case, it's time. Obviously, there's no one to compare it to, so let's just compare cake to cookie, 6 minutes for 60 minutes. 6 minutes is like, quote, better because it's fewer resources. So that's basically all of Unit 1. Let's go to Unit 2. This is about 20 to 25% of the quiz, so we're talking about 12 questions here with things about this. This year we started with utility, we started with marginal utility and utility maximization. So let's do the utility max rule. And you will definitely see questions on this. And what you need to do is when you're consuming 2 goods, you need to consume, so the marginal utility per dollar, this is key, it's per dollar, of good A equals the marginal utility per dollar of good B. And they will give you like the last unit consumed, and let's say the last unit consumed of an orange was 10, and let's say the orange cost $2, and let's say the last apple consumed gave you a marginal utility of 20, and the apple cost $5. That's an expensive apple. So be it. So 20 divided by 5 is 5 marginal utility per dollar. So basically, every dollar gets 5 utils of happiness. And here, 20 divided by 5 equals 4. Now, all these numbers are made up. But what's important is the AP exam in the midterm will give you something very similar, a 5 and a 4. And they'll say, did you consume correctly? And I know 5 and a 4 are very close to being the same, but they're not the same. So what we need to do when we get to a situation with 5 and 4 is we need to consume more here and consume less. The reason that is because of the law of diminishing marginal utility. The more you consume something, the less additional happiness you get. So if it's 10 divided by 2, the next time I consume the apple, it might be, sorry, this is the orange. The next time I consume the orange, it might be 8 divided by 2. Or 9 divided by 2. Let's call it 9 divided by 2. And here, if I consume less apples, the marginal utility will rise, so it might be 22 divided by 5. And you want to do it so the numbers become totally equal. So we would consume more, consume less. Let's go to demand. So the thing, they used to ask a lot more. Now they're not asking as much about it, but it's demand versus quantity demanded. So this is going to be due to an exogenous variable, and this is due to an endogenous variable. Our only endogenous variable that will affect quantity is price. Quantity is our dependent variable. So let's just set up the two things here. We have two demand curves. And a change in demand caused by an exogenous variable means if we're at a certain price, let's say demand increases, then what we're saying is even at that same price, consumers demand more quantity of this good. Regardless of price, people want more of this good. That's a change in demand. So that's an exogenous variable. So this is anything outside of our model. It could be substitute goods, complement goods, income of consumer going up, going down. It could be trends in society. It could be tastes. It could be, I mean, there are so many examples for demand change. Here, what we're saying is quantity demanded increases because price goes down. The only reason people are consuming more of this good is because price is lower. The example here is when you go into a supermarket and you were going to get one box of cereal. What's the best cereal? Obviously Captain Crunch. You're going to buy one box of Captain Crunch for $3. You go, it's on sale. That's a terrible take, Francis. Captain Crunch. And if you wanted Crunch Berries, that's not the answer. It's plain Captain Crunch. So let's say you were going to buy one box for $3. You go into Shaw's, it's 50% off. So instead of buying one box for $3, you're going to end up buying 2 boxes for $1.50 each. The only reason you consume more Captain Crunch is because because price went down, so your quantity demand went up. The reverse is now that we are live streamed and we are broadcasting to over tens of people in the mods only, exclusively in the mods. Everybody, you're supposed to louder laughs, Big Al, louder laughs. If everyone hears, all 10 of you hear that Mr. Strite likes Captain Crunch, and you run out to buy Captain Crunch, you're like, I don't care what the price is. Strite eats Captain Crunch. I gotta get Captain Crunch. That is demand increase, and quantity increases regardless of price. So that's an exogenous variable, a change in demand versus a change in quantity demanded. And again, that used to be more important. It's less now. let's do concurrent shifts. There will be a lot on supply and demand shifting and what happens to price and quantity, but I think you guys are really, really good at that, and I think that comes up when we do other markets, and I don't want to spend too much time on that. But maybe just basically, we're going to graph, make sure you label everything, supply, demand, P1, price, quantity. Bless you. So let's talk about concurrent shifts. And the first time I introduced this in class, I think it's an overwhelming concept because a lot's happening. From everything we've done since October, I think this is very straightforward now, and I don't need to spend too much time on it. And it's kind of fun to revisit, to go back and be like, oh, I wish I had these questions now. But you do, you get them on the midterm. So concurrent shifts is if demand and supply simultaneously shift. So they'll be like, in the market of sugar, there's an increase in technological advancement, while at the same time, Americans are more concerned with diabetes and consume less sugar. So in that case, we would have an increase in supply. Supply would shift to the right, and demand would shift to the left. With the supply shift, what I would like to do, and again with concurrent shifts, I like to graph them differently. So supply increases due to the technological advancement of the production of sugar. And when supply increases, price goes down and quantity goes up. Due to diabetes fears, people consume less sugar, demand goes down. When demand goes down, price decreases, quantity decreases. Then I compare my shift in demand with my shift in supply. I see that price is going down in both scenarios. So with these, if an increase in supply and a decrease in demand happen, price will definitively go down. We are confident, we're positive this is going to happen. However, demand, quantity goes down, quantity goes up. I'm not sure what's going to happen. It could be that demand shifts more than supply. Supply might shift more than demand. It could shift the same. It is indeterminate. And this is a good word. It's not that I don't know, it's that I can't know. So that is a concurrent shift. As we're with supply and demand, let's talk about elasticity. And it's how sensitive quantity is to a change in price. We have elastic, horizontal, and we have inelastic. Vertical. So an elastic curve, it could be demand, it could be supply. And again, thanks to Alfred Marshall, we have the reverse slope here, so we've run over rise. So elastic is more of a horizontal line. Inelastic is more of a vertical line. And what we can do here is we could do a small change in price leads to a very significant change in quantity demanded, or a more significant change in quantity demanded. I'd hate to talk in normative statements in a review real quick. You might see it. Normative is an opinion. What's very significant, I don't know. Positive is a statement that's database claim. So in this case, we could say that the change in quantity demanded will be more significant with an elastic than an inelastic. We have data to show that. I'm about to do that right now. So we go P1, basically the same change in price. And you can see as price decreases, quantity demanded is less sensitive in the inelastic demand curve than the elastic. So we'll rule with that. If price goes down and it's elastic, total revenue goes up. With inelastic, if price goes down, total revenue goes down. We want the higher price here and the lower price here to increase our revenue. So that's the difference between elastic and inelastic. You might have some questions on the coefficient. So we also have unit elastic, which is change in price leads to no change in total revenue. And that's basically a slope. Think about it. Elasticity and slopes are not the same thing, but they're related, and it might help to think about it at times as the same thing. So a unit elastic as a at 1 means a 10% change in price leads to a 10% change in quantity demanded. So there'll be no change in total revenue. You're losing 10% of your price, but you're getting 10% more customers, so the revenue is going to stay the same. We have perfectly inelastic, which is 0. And that will be a vertical line. And then we have perfectly elastic, which is technically undefined, but we're going to call it infinity, and that's a vertical line. And everything is about absolute value and we'll go somewhere in the range of greater than 1 or less than 1. If you're less than 1, you're elastic. If you're greater than 1, you're inelastic. Oh, did that wrong. If you're greater than 1, you're elastic. That's the problem with live. Now it's on there forever. So here we go. We're greater than 1, it's elastic. Less than 1, we're inelastic. 0 is perfectly inelastic, and infinity is perfectly elastic. It's a straight line. The calculation is percentage change of quantity demanded or quantity supplied over percentage change in price. Remember, we talked about it earlier in the year, that stupid example of you don't want to sleep on cats or slushies. You always want to sleep on a bed of money. Money goes under the mattress, so money goes underneath here. There are a couple of relationships with elasticity. There's cross price, which is percentage change of quantity demanded of good A over percentage change in price of good B. So this is, are they substitutes? Are they complements? If their relationship is positive, that equals substitute. So you plug in your examples. If the price of Coke goes up, the demand for Pepsi goes up. Negative equals complements. If the price of cars goes up, the demand for gas goes down. So a negative relationship is complements, a positive relationship is a substitute. And then we also have income elasticity. And that's percentage change of quantity demanded over percentage change of income. Positive is a normal good. And everything's relative here, but if incomes of an area go up, demand for eating out at restaurants goes up, normal good. Negative relationship would be inferior. If incomes in an area go down, demand for fast food, public transportation goes up. So, and it's all relative, but that's a normal good and an inferior good. Surplus. Perfectly competitive market at equilibrium is the best you can be in an economy. There's no deadweight loss, there's maximum surplus. This is the most efficient an economy can be, and it can only happen in a market economy. And we know at this price, we have maximum producer surplus and consumer surplus. We will call this socially optimal or allocatively efficient. We break down these words. Socially, that's for society. Who makes up society? We have the consumers, we have the producers. So this is best for both of them. Allocatively efficient, to allocate is to distribute, efficiently is the best. This is the best distribution of resources. So this is efficiency at its best. This is why markets are more efficient than command. Consumer surplus, producer surplus. Now, let's do floors and ceilings. Floor is a legal minimum. You cannot go below a floor. There I go. Here I am still standing. Very good. Supply, demand. So I'm going to write this as floor. Is this a floor? Yes, of course. How do I know that? It says floor. But does this floor do anything? No.
What about the upside down house?
Thanks, Francis. We're getting there. The floor is not doing anything and is not binding. It is still setting a minimum, but since we're going to be at equilibrium, the floor does nothing. Now, the upside down house, if floor is above, now we want to be at equilibrium, but it's preventing us from being there. So when the floor is above the price, what happens if we have a decrease in quantity demanded, an increase in quantity supplied, this becomes producer surplus, this becomes the consumer surplus. And these are transactions that used to happen that are no longer happening. That's called deadweight loss. Deadweight loss is the loss of surplus due to government intervention, the command, taxes, floor ceilings, due to market failure, oligopolies, MOCOs, monopolies, or due to externalities, positive or negative. But we know this market is not working correctly. It's not as efficient as it should. We are losing surplus. Now I'm going to do the same thing with the ceiling. A ceiling is I'll write it up here, is legal max. Good example of a binding floor is minimum wage. Example of a legal ceiling would be rent control. A limit on how much you can charge something. So here, is this a ceiling? Yes, of course it is. How do I know that? It says ceiling. But does this ceiling do anything? No. The ceiling says we can't go above it, but we're at P1 at equilibrium. We're not going above that. But if I bring the ceiling below, now the ceiling becomes binding. And here's the quantity supplied at the ceiling price. Here's the quantity demanded. This is going to be my shortage. And here are all the producers and consumers who used to be able to make the legally binding ceiling. My consumer surplus for those buying the product has increased. My producer surplus for those selling it has decreased. And that's a binding floor and a binding ceiling. And to help you remember, we have that terrible image of the upside down house. And if we put that into our supply and demand graph, we have the ceiling below and we have the floor above. Now let's talk about taxes. So with taxes, what we do is we could use this model to show how taxes are always split between the consumer and the producer. Let's say we want to have a tax that's that much. If I were going to levy that tax solely on the producers and say this is what P1s are equilibrium price, this is going to be the price producers pay. Well, there would be very little of this product produced. The quantity supplied would decrease drastically because producers are getting so little of this. So what naturally happens is the consumers and the producers, based on the elasticities, we'll show this later, they end up splitting the tax. So I'm going to put the tax in here, and this is the price consumers pay. Here's the price producers receive. And I'm going to go to the demand curve. I'm going to go down to the supply curve and over. Here are all the producers and consumers who are out in the cold. They're unable to consume or produce this good due to the tax, deadweight loss. This box, here's my tax. Here's my quantity with the tax. So this becomes my tax revenue. Here's my consumer surplus, and this whole thing becomes my producer surplus. So that's how to effectively draw a tax in a perfectly competitive market. Now, the distribution of the tax, who pays more, the producers or the consumers? At this point in the game, this should be incredibly logical to us. If a curve is inelastic, that means a change to price does not lead to a significant or as significant change in quantity demanded. So if we're in a market that has either necessity, so like medical, stuff like that, or has an addictive quality, this is why there's such a high tax. For two reasons there are high tax, but one of the reasons there can be a high tax on things like cigarettes, tobacco, and alcohol. And now in this state, marijuana, because, well, marijuana is not an addictive quality, but there's an addictive quality to these where people are dependent on them. Also, if you tax something, you reduce the consumption, the negative externality of that as well, which is the other reason. But let's take a market that has a relatively elastic supply curve and a relatively inelastic demand curve. And this was going to be our price before. And let's say this is going to be our tax. And again, if we put the tax just solely on the producers, we'd be making kind of none of this good. So even if we split it 50-50, you can see that we'd have significant decrease in quantity in the market. So what we're going to do, what naturally will happen is, let's put it up here. Let's go over, then we're going to go up, and then over. And you can see that this is the price the producers get. This is what consumers pay. And this is the quantity with tax. Now, there's less deadweight loss in this market than a previous market because the demand curve's more inelastic than in our last market. So there's a more significant increase in price of the consumers, but because the curve is relatively inelastic, quantity demanded is less sensitive. So this is my consumer surplus, my producer surplus, and this is my tax revenue. Externality is consequence, impact on a bystander. People who do not have skin in the game, who are, there are as simple things as if your neighbor has a really, really nice front yard, a really nice display of flowers, and it's beautiful, and you get to walk by it every day, and walking by it makes you feel happy. You didn't buy the flowers, you had nothing to do with the flowers, and then all of a sudden you're benefited. That's a positive externality. We just got through kind of the winter holiday, and if your neighbor had like 1 million lights on their house and Rudolph and all this loud Santa stuff, and it was like kind of an obnoxious eyesore, and it was hard for you to sleep because the lights are shining in your room, that's a negative externality. Those are simple things. Now there are more examples of that when we talk about pollution, we talk about education, we talk about vaccinations. So let's start with just our market and equilibrium. And with externalities, we'll call this the marginal private cost. So this is the cost of the producers, and this is the marginal private benefit. This is the benefit to consumers. And this is where they value it. We're at Q1 and P1. So let's say this is a negative externality. Like smoking. Smoking has an impact on those who do not smoke. If there are people who smoke, they cause pollution, which has impact on many parts of our lives. But beyond that, they drive up their medical costs within a society. If you're a smoker, you're more likely to have long-term health problems, which means you're going to be a drain on resources, medical resources that are scarce. Everything's scarce, but are more scarce than other markets to begin with. So let's say the cost is every time someone smokes a pack of cigarettes, I forget what it was like 30 or 40 cents per pack. If you're a pregnant woman, it was something as much as I think $3.50 per pack, which is the cost to society. So it's an additional cost to society. So this is called the marginal social cost. If someone is smoking cigarettes right now, they are costing me, they're costing you, they're costing everyone in this room 13 cents or 30, I forget what the number was, per pack of cigarettes. And what we mean is this is the private cost, and we go up here, and this becomes the social cost. This triangle in between becomes the deadweight loss. And with negative externalities, what economists and what economic theory says, and this isn't true for all things, but generally speaking, economists say don't get rid of it entirely, but there's too much of it in society. And that's what the deadweight loss is caused by. That this is the socially optimal, here's our quantity, the difference between the two is deadweight loss. There is too much product. In a negative externality, the private marketplace is producing too much of this good. So what we need to do to get rid of it is we need to do a per unit tax. And that will get rid of the deadweight loss, and then we'll be producing at a higher price and a lower quantity. The only way to really diminish quantity demanded is to raise price. As we've seen, a lump sum tax, and now it's easier to talk about, a lump sum tax does nothing to MC equals MR. It just changes average total cost. So a lump sum tax doesn't change production. But a per unit tax would decrease production and would raise price. That's why it has to be per unit. Now let's reverse the colors and let's go to a positive externality. So what we're saying here is this is like education. There's a price, and let's call this college. This is a positive externality. When people go to college, me, Mr. Strite, I am positively impacted by that. And these are people I've never met before. These are people who may or may not live near me or around me. But me, society, is positively impacted when people go to college. So we have the marginal private cost of college and the marginal private benefit. So when people make the decision to go to college, they make it based on their own lives. What is college worth to them? what is their benefit for going to college, and colleges and universities set the supply based on their own costs. But what I'm saying with a positive externality, and this is the marginal social benefit, is that other people, like me, are benefited. And with the deadweight loss, you can draw the deadweight loss above, you can draw it below too. Not in both places, one or the other. So here, this can be my deadweight loss, that's fine. The triangle above, because what we're really saying is this is the private benefit here, and this is the social benefit. And this is, when people go to college, this is what happens to me, my family, this is the benefit I get out of, whatever that is. So what we have to do to correct this is a per unit subsidy. It cannot be a tax because a tax is, cannot be a tax. It cannot be lump sum because lump sum doesn't change quantity, it doesn't change price. It has to be per unit because per unit changes MR equals MC. We went from unit 2 basically into unit 3 and into unit 4. We're kind of in command now. The command will be about 15%. But there are just a couple quick things I want to go over. We have the Laffer curve. Yeah, it's a good one. Thank you, Tony. So we have, this is tax revenue. This is tax rate. And it basically shows the elasticity of taxes. So when your tax rate is 0%, you have no revenue. When your tax rate is 100%, you have no revenue. No one is going to work and give 100% to the government. They're just not going to work. I can either work and give all my money to the government, or I cannot work and not give my money and not have any money. I have no money either way, so why would I work? But there's some point in here in which kind of the tax rate becomes or elastic. You lower the tax rate to increase revenue, it would be inelastic. The other curve is the Lorenz curve. So this is population, and this is wealth or income distribution, or income percentage. I think wealth is an easier way to say it. This is the line of equality. So the way to read this is if the line is perfect like this means 80% of the population owns 80% of the wealth, 60% owns 60%, 40% owns 40%, 20% owns 20%. The wealth of a country is distributed perfectly. The Lorenz curve will deviate from the line of equality and will show the wealth gap or the income unequal distribution within a society. So in the United States, it's something like 20% of the population owns 80% of the wealth. And then it gets even worse, like the last 5% of the population owns 20% of the wealth, so on and so forth. I think it's 60, whatever. The last 5% of the US population owns 20% of the wealth. That's the one that matters. I think the first one was totally, horribly inaccurate. But that's the Lorenz curve, and it shows the further you are here, or the higher your Gini coefficient. This is also showing the Gini coefficient. The more inequality exists within your society. So with the Laffer curve, the Lorenz curve, there's one other random thing I wanted to talk about. It'll come to me or it won't. Let me take a drink of water to lay here.
Is it the course theorem?
No, that was I was thinking that. That one I hate. That's the stupid extra. Yeah, we could guess. We could talk about that. Yeah, it's that, and then Pigovian tax is the other one. So the course theorem is so dumb. It's even worse because I don't know how to spell theorem. Or we go UM, EM. Is there a U in there?
No.
Perfect. There's an O. I got the O. Good there. That's, there's no R? Coast? All right, here we go. This is how important the coast theorem is. So basically, the coast theorem is a way to solve externalities. So let's say, Ellie will use you because you're filming.
Okay.
Ellie has a tree. And she saves $200 a year in heat. And let's say the tree goes on Emma's property and she has to spend $300 a year to clean it up. The coast theorem says to solve this negative externality, Emma should pay Ellie less than $300, but more than $200 to get rid of the tree. And that's the solve of the coast theorem. It's a way to work out externalities between private citizens or outside of government regulation.
Did you mean private goods before? Like law?
That's a good one. So let's spend one quick time. Let's do public. Oh, that was in great English, huh? Public, private, common resource, and semi-public, or this is really a natural monopoly. So this is not excludable. Non-rival. Non-rival means multiple people can use it or observe it at the same time. For example, if you were doing a review session and you're at capacity, maybe you put it on something like YouTube Live, and then it becomes non-rival, so multiple people watch it at once. Versus when I did this last year, and I had like people stacked to the ceilings, and then people couldn't get in, and then it became rival for those last people. They just went home, and they all failed the test. Non-excludable. Now I can prevent, this is a public good, look at us. I can prevent people from coming into the classroom. I have a lock, I have a key, I can say, nope, we're at capacity, you can't come in. But my YouTube channel is open to the public. Anybody can watch it because it's non-rival. Anyone can watch it, multiple people can watch it at one time, non-rival. I can't prevent people from watching this, so right now we are a public good. A private good means excludable and rival. When one person is using it, someone else can't use it. You can prevent people from using it. I mean, the easiest thing right now, I'm wearing a sports coat. This is a private good. If I'm wearing it, someone else can't wear it. If someone asks me to wear it, I can say, no, I don't want you to wear it, it's mine. Excludable, rival, simple as that. A common resource is rival, but non-excludable. And this leads, if there's demand, to the tragedy of the commons. Tragedy of commons can be applied to international fishing, can be animal poaching, can be applied to deforestation, to pollution, carbon emissions. It's the idea that you can't prevent people from doing it, but when someone does it, it takes away. So for example, when we talk about fishing in international waters, we had an issue with the whales at the turn of the 19th century as well. Well, if you fish a whale, you kill a whale, you get a tuna, it's dead, it's gone, no one else can get it. It becomes rival. However, in international waters, you can't prevent people from fishing. You can't prevent people from whaling. I mean, there are laws now, but for a while it got overfished, it got overwhaled, and that's a tragedy of the commons. And then a natural monopoly is excludable but non-rival. Examples of this are utilities where they can prevent, Comcast can prevent you from using their platform, from having their internet, their cable television, but once you're using it, your neighbors can also use it. So that's natural monopoly. Movie theaters are like this too. Multiple people can watch a movie at once, but when someone's watching it, you can also watch it. Private goods by sports code, and this YouTube stream is public. The problem with public goods, the AP exam loves to ask this, the problem with public goods is that they're non-excludable. So nobody can make money off of it. So they become underproduced. And they're normally provided for by the government because the private sector won't do it. Like Amazon's not going to try to make more money putting up fireworks displays around the country. They would make no money because you can't charge people for a fireworks display because nobody would pay for it. They just go a block back and they look up in the sky and see the fireworks. So that's why fireworks displays are provided for through taxes, through local governments, through city governments, that sort of thing. Same thing with public defense. Examples in the Mankey book was the tsunami siren, public parks, public roads. That is all examples of public goods. Okay, those are our goods. Make sure I'm not missing anything. Can do without that.
What unit are we on right now?
We are about to start Unit 5. We got 3 to go. Boom, let's do costs. Let's start with the very basic here. These are all of our cost curves. Let's start with our first cost curve. The most important cost curve is marginal cost. Why is marginal cost shaped this way? Initially, it decreases due to specialization, and then increases due to overcrowding and diminishing marginal returns. Right here, this point, the bottom of the marginal cost, the lowest marginal cost, that is when our marginal product curve will be highest. That is when the next or the last worker provided is the most productive. Let's do our next cost curve. Let's go average total cost. Average total cost intersects with marginal cost at its minimum. This is also the productively efficient point. Marginal is the next, average is the average, it's the total divided by the quantity. So if your average, if the next item produced costs less than your average, it's going to bring down the average. We use the GPA analogy in here. I think the sports analogy is good too with a basketball player. If a basketball player is averaging 33 points per game and they score 14 in the next game, their average is going to come down. They score 20 the game after that. Even though the marginal score is increasing, it's still below their average. It's going to come down. Finally, when they intersect, if marginal is greater, if they score 45 points, that'll bring up the average. And if they keep going, the average will go up forever. The next curve we're going to add here is the average variable cost. What's important about the average variable cost is the gap between ABC and ATC starts out fairly significantly and gets closer. The reason is average total cost is made up of the ABC and the AFC. ABC is obviously just ABC. So let's look at our AFC. And AFC is your fixed cost, which never changes, never changes. Once you begin production, you have your fixed cost, and it's divided by quantity. As quantity increases, you have a constant being divided by an increasing number. So AFC will continue to decrease. It will never hit zero, which is why the gap between ATC and ABC will get closer, but they will never, ever, ever hit, they will never touch. Those are our 4 major cost curves in the short run. I know I'm in the short run because I have a fixed cost. I know I have a fixed cost for 2 reasons. I have my average fixed cost, but also I have 2 different cost curves. I have ATC and ABC. So let's go to the long run. In the long run, to quote Kevin Garnett, anything is possible. Literally, you can expand to 20,000 stores. You can contract to 0 stores. The Boston Red Sox can play soccer on the moon. I mean, in the long run, you can change any of your costs. So there are no fixed costs, just average cost or average total cost. So what happens is it's going to look like this. And we're going to have 3 sections. This first section is called economies, or increasing returns to scale. Economies of scale is as quantity increases, average total cost decreases. You won't need the specifics on the AP exam, but the reason this happens is if we take like a tiny little local business, I like to use Anna. We did Stripe Pizzeria, but I like Anna's Taqueria. When Anna's was 1 store, they were confined space. They had to store everything there. If the avocados went bad, they went bad. They would have to buy more avocados. They couldn't buy in bulk because the store was tiny. As Anna's, I think now is like 10 locations in Boston. Now they can buy in bulk. So when you're buying more in bulk, the average total cost is already cheaper because you divide up the fixed cost. Additionally, they cut waste. They use the better resources. If they have avocados going bad at 1 store, they just send them to a different store, and they don't waste product that way. So as quantity increases, ATC increases. So we have like a ratio of input to output. So here, let's say we increase our input by 100%, maybe we get 200% output out of it. So as we continue to produce, we're getting more efficient at producing, so we get more out of our inputs. Here is our returns to scale. And this is our lowest average total cost. We're the best at producing. We're probably producing some of the goods ourselves. And here we have an input to output ratio of 1 to 1. If I increase my input by 100%, I increase my output by 100%. And then our last part is diseconomies of scale. Also known as decreasing returns to scale. And here, as quantity increases, average total cost increases. The reason this is we're now paying for things that we didn't have to pay for when our business was smaller. There could be bureaucracy, communication issues, advertising. I mean, we went through the international expansion of Stripe Pizza, and there were all sorts of costs that didn't exist before. Marketing, that sort of thing. I mean, we're entering kind of the oligopoly range here as well. But, I mean, immensely profitable, but a positive statement is quantity increases, average total cost increases. Now, I said this is also known as decreasing returns to scale. And you might see that on the exam on the midterm. If this is returns to scale right here, how do we get there? We decrease output. Here, this is also known as increasing returns to scale. So if this is returns to scale, how do I get there? I increase output. Returns to scale, it's normative to say returns to scale is better. All returns to scale is the lowest average total cost. A lot of businesses prefer to be here because they're making so much money because they're globally expanded. Cool. Two other things here. We have the cost minimization rule. And this is if I'm using two things. Let's say I'm using labor. So the marginal product of labor per dollar has to equal the marginal product per capital per dollar. This is the same idea as marginal utility per dollar of A has to equal marginal utility per dollar of B. So let's say I have labor, and let's say my laborer can make 100 hats, and my laborer costs $50. And let's say my machine can make 3,000 hats, it costs $1,000. So for every dollar I make 2 hats here, every dollar I make 3 hats here. What I want to use in the same idea as marginal utility per dollar, if you get a question like this, 3 to 2, it's less labor, more capital. Again, K for capital, they can't use C because it would confuse you with cost, so that's why I use K for capital, but capital starts with a C. So here we have less labor, here we have, use less labor to increase marginal product per dollar. And here we want to use more capital to decrease marginal product per dollar. The reason marginal utility decreases as you consume more is the law of diminishing marginal utility. Why marginal product decreases as you produce more is the law of diminishing marginal returns, overcrowding. Different reasons why this happens, but it's like the same exact idea and concept. So now let's talk about our favorite thing, accounting profit. And economic profit. So accounting profit is total revenue minus explicit costs. Accounting profit is total revenue minus explicit costs and then you subtract implicit costs. So the difference between economic profit and accounting profit is the implicit cost. Economists think of implicit costs, accountants do not. So if this is price and quantity, this is my total revenue. If I subtract my explicit costs,
It's just right. Sorry, the video's like frozen.
ooh, we've never done this before.
Okay.
What
Someone by the other room.
yeah, see.
I don't know what.
What guys are this doing?
It's like frozen.
And I was gonna ask, for both things, use the bigger number, like the cost minimization and the margin utility one. Choose the
I'm
bigger
sorry.
number.
Wait.
Yeah.
Pretend to ask, you left the room.
Yeah.
I was gonna ask
The bigger
you.
Anthony, if the numbers are equal, don't change anything. If
No,
they're
it's
uneven,
27%.
get more of the bigger number and.
I think we're in a different vortex. They can hear me, but they can't see me.
So like, you might
that's the best
change the number, make
I
sure.
guess.
It's
We're
awesome.
fixing it, people. Okay.
Thank you.
Try to
Stop videoing as well.
exit out and like.
I'm worried if I exit out.
It'll like delete. the
Yeah.
whole thing. Don't do that.
The whole screen's frozen, yeah.
Yeah.
I'm taking furious.
Okay, try and close
They
it
can hear
out.
everything we're saying, just be careful.
Yeah.
Yo, okay, the other room's trash though.
Use a cable.
Thanks, Big Al.
I think the whole thing's frozen, so I want you exit out.
Can you close it out, save it?
It's like not happening.
Oh, I have an idea. There it is.
Phil, say FaceTime.